Hello, everybody. Here we are, 7.3 Similar Polygons. And the notes, I just have an image for you in the notes section. So let's read over it. Some properties of similar polygons. The word similar has a specific meaning in math, and we'll see that in a little bit. So when two polygons are similar, their corresponding angles are equal. You can see in this image, each of these angles is represented by the same symbol or number of lines. So this angle right here is equal to this angle shown by two lines. This angle right here is equal to this angle shown by just one line. This is a 90 degree angle, so it's shown by the square. And then this angle right here is shown by this little snowflake or something like that. And in a similar polygon, their corresponding sides are proportional. And I want to point out, in a polygon, we need both of these things. So you might have, for example, something like a rectangle, or a square like this, and a rectangle like this. And these have, equal angles. They all have 90-degree angles. But they need also to have proportional sides to be similar polygons. So we'll find in our next section with triangles is an either or, but for similar polygons, it's a both. And it is true that if two polygons have these properties, then the properties are similar. You'll see similar represented by this symbol right here. You can't see it that well in the notes, but it's just kind of like a little S like that. So this is saying that quadrilateral ABCD is similar to quadrilateral PQRS. And we can confirm this. We see that our angles are labeled with the same symbol, so we know that they are equal. And we should have the same proportions for each of these sides. So they've showed that, for example, side AB, they've lined it up with PQ on the other one. And side BC, I want a different color. Side BC should be the same or proportional to QR. And that side CD right here should be proportional to RS. And then finally, side DA should be proportional to SP, like that. And we can check. How we can check is by seeing if they make equivalent fractions. So AB is 1.5 over PQ is 2.1. Should be equal to BC, which is 3.0 over QR, which is 4.2. And should be equal to CD, which is 3.0 again, over 4.2 again, and should be equal to 2.0, that's DA, over SP 2.8. And if we put each of these in our calculator, we should get the same decimal. So we have, I'll move this for a second. Hopefully you can see this. 1.5 divided by 2.1 equals, let's do 0.71, equal to 3 divided by 4.2, 0.71. This is the exact same fraction, so I know it's the same. And our last one, 2 divided by 2.8. I'll be shocked if it's not. Divided by 2.8 equals, there you go, 0.71. So we know these are similar. They have the same angles and their sides are proportional. So let's do a question. Calculate the missing variable. There's more examples on page 341. So we want to check, we know nothing of the angles, but we can check that the sides are proportional. So this side right here should be proportional to this side to this side, and this side to this side. So it should be true that, let's do this side, should compare to this side. So 1 over 2 should be equal to the proportion of 2 to 4. And should be proportionate to 3 to we don't know what. We don't know what. Okay, and so there's a few ways, I guess, to think about this. You might just guess it by looking at it. But let's do it. If we did 1 divided by 2 as a decimal, we get 0.5. If we do 2 divided by 4, the decimal is 0.5. And so we want something that's going to give us 0.5. I mean, you can see it's going to be a 6. But let's show you what that looks like. 3 over x. So we know that 0.05 is going to equal 3 over x. And we'll give us a little bit of space. As we've been practicing, we now need to solve for x. How do we get x out from under the bottom? We need to multiply by x on each side. Oops. Times x. Those cross reduce, and so we're left with 0.5x equals 3. And then we can divide by 0.5 on each side to get the x by itself. And our answer should be 3 divided by 0.5 equals 6. Imagine that x equals 6. You can see that this side length is going to be 6. Okay, there you go. You kind of can see how you're getting to the next step here. But there you go. That's how you'd solve that one. Let's do the next one. Which rectangles are similar? Give reasons for your answers. So we're looking for proportional sides. So this side, if they are proportional, should be proportional to this side, which is also 1.8. And this side up here should be proportional to this side up here. So these are the ones we're comparing and seeing, are they similar? Let's get this color right here. So let's check. Let's do 4.5. Let's do A. 4.5 over 2.7 should be equal to 2.7. So this side right here from A. So I'm going to do a label that I have the B down here. Should I use different? I'll use different colors. Here we go. So 2.7 should be equal to, what am I doing? 2.7 over 1.8. Colors are a bit messed up because I've used the same color for these sides, but then the same color for different, for the A and the B. Hopefully I haven't messed it up too much, but hopefully you get the point. I'm comparing this top side of A to this top side of B, and this side of B, this side of A to this side of B. They should be proportionate. Let's see if the decimal is the same. So it should be that 4.5 divided by 2.7 equals 1.6 repeating equals 2.7 divided by 1.8, 1.5. So these are not equal. They are not similar. Okay, let's check out B and C. So let's make a similar looking set of fractions. So let's go B, and we're going to compare the top side, 2.7, over this top side, 1.5. Just use the same colors. I think we'll get it. And we'll use this side, 1.8 over 0.9. And again, we should get the same decimals if they are similar. Let's check it out. We have 2.7 divided by 1.5, 1.8 equals, what are we doing? 1.8 divided by 0.9, 2. They are not equal. So B and C are not similar. But let's check on A and C. So let's see about that. Let's look at A. Let's compare our tops. 4.5 to 1.5 should be equal to our sides, 2.7 over 0.9. And let's see what we get. We have 4.5 divided by 1.5, 3 should be equal to 2.7 divided by 0.9, and it is 3. So A and C are similar. I'm putting an exclamation mark. I feel thrilled. Okay, let's look at our next ones. So this one, I mean, I think is a good example of why, seems like we have the same fraction, or sorry, we have the same angles. They're all 90-degree angles, but these two aren't kind of, their sides aren't growing in the same proportion. They don't have the same, this one, if you multiply each side by 3, you're going to get to here. So they have the same they have a scale factor of 3. And this one is 1 over 3. This is a third of this one here. So let's do our last one together. These polygons are similar. Okay, so they gave us this piece of information. They said they are similar. So what we can assume about them is that their angles are the same and their sides are proportionate. That is embedded within that word similar, and we can safely assume that. So determine each length. They want us to determine PT, so this side right here. And they want us to determine BC, this side right here. Okay, so we have, what we can do is kind of compare sets of unknowns for sets of known things. So what we know is that the relationship between these two sides, we know both of them on each. So if we find the relationship between these two, it's going to be the same as the relationship between these two. So if we have 8 over 3.2, so let me, maybe I should do some colors. Maybe that will help you. So this side right here over this side right here. So if we have 8 over 3.2, it should be equal to the relationship between, let's do purple, this side right here, 6, over this side right here, the PT. So let's do PT. And now we can cross multiply and divide. We can, when we're cross multiplying and dividing, remember you look diagonal first. You multiply the two that are both numbers and then divide by the third one. So we're going to do 6 times 3.2 divided by 8 should equal PT. So let's do that. 6 times 3.2 equals 19.2 divided by 8 equals 2.4. So we got that one, 2.4 right there. And we can check that this answer is correct. We can say, oh, this one to go away. Oh no. Here we go. We can check, we can say, is it true that 8 divided by 3.2 equals 6 divided by 2.4? We can check this. We can say, okay, 8 divided by 3.2 equals 2.5. And this should be equal to 6 divided by 2.4, 2.5. So we can be certain that we did that right. So let's do the next one. We can use the same relationship if we'd like. So we can use the same information that 8 divided got cut off at the very end, but here we are. We can use the same relationship that 8 over 3.2 should be equal to, what do we need to find here? BC over 2. So we can compare BC to its corresponding side right there. So it should be equal to BC, which is what we need to find out, over 2. And then we can do the same cross multiplying and dividing. We look diagonal. We can see these are the two numbers that are diagonal from each other. And we're going to divide by the third one. So we're going to have 8 times 2 divided by 3.2. So let's do it. 8 times 2 equals 16 divided by 3.2 equals 5. Sorry, we should say BC equals 5. And we can check this. Remember our ratio here, 8 divided by 3.2 is 2.5. So we should check again. Is it true that 5 divided by 2 equals 2.5? I mean, I know that it is, but let's do it anyways. 5 divided by 2.5 equals, 5 divided by 2. Wow, I was shocked. Divided by 2 equals 2.5. So yes, they are proportionate. There we go. I will let you know what textbook questions I would like you to do. Where did we go? There we go. Thanks so much.